This video deals with motion and graphs in terms of velocity versus time graphs, which you can kind of see listed or located over here on the side. It's a continuation of the video we previously went through where we talked about distance versus time graphs. You'll notice this time the axis has shifted up a little bit. These we kind of left down here in the bottom, but this one needs to be in the middle because there'll be times we have negative and positive velocities. So starting with the first graph, when you look at this, we have an object that is at rest. Well, hopefully that's a pretty easy one to understand, that should be a graph where the line stays right on the x-axis. Because if you don't have any velocity, you can't be above or below that, and you must be at 0. Now we have ones that are a little bit more difficult, but not much more difficult than what we just got done doing. This time we have a constant positive velocity, and what we did to do that on the previous graph is we had a straight line that went up. Well, in this one, you're still going to have a graph. If you have a constant velocity, you can't be changing your position on the y-axis. All you can really be doing is moving to the right. So because this is a positive constant velocity, we will be right there, or anywhere that this was, let's say, 5 meters per second for the slope, then that should be a 5 meters per second for your y-intercept. And for this one, here's a negative constant velocity. We'll notice the slope is constant, which means we have a velocity is constant, and that would have to go below the x-axis. Again, with a straight line that goes across, indicating our speed's not changing. Neither of those are really too difficult to work with. Increasing positive speed. So now we have something that's going to be slightly different. Here our slope is going up, and an increasing slope basically indicates we're going to have some type of a positive, wrong tool there. We're going to have some type of a positive acceleration. Slope goes up, acceleration will go up, which means our velocity should increase also. In this case, we started from rest and we went up, so that's where that one's going to go also. This one also started from rest because it's relatively flat up here, but this time it will go the opposite direction. This one's going to go down because our velocity is increasing in a negative direction. So we started at 0 and we slowly work our way down the y-axis. This one we went from 0 and slowly worked up that y-axis. You know, if you're going into a higher and higher velocity, here's a lower and lower velocity, but a more negative velocity, which means the speed is increasing, but it's going to be more negative. Last two are a little bit tougher to deal with just because you have to think a little bit. Again, we have a decreasing slope. What's happening? We're starting with a positive speed that we're slowly losing. Well, that indicates we're going to have some type of a loss of speed. So we're going to have some speed and go down and approach 0. So eventually we get to here, and then maybe at this point we would level off and continue to go that way. So it's a decreasing positive speed. We have to be up in the positive quadrant to indicate a positive speed. Here we have a negative speed, which puts us down here in the negative quadrant, and it's eventually going to slow down to a stop. So again, we would start with some negative velocity, approach 0 and eventually get to 0, and then we just work our way across this x-axis at a stopped speed. So those are our variations for velocity versus time graphs. Again, none of those are really terribly difficult. It's more along the lines of what's happening with the previous graph to help us understand what we're doing with the next graph.